Imagine creating details for thousands of students one by one. Their names, their ages, their roll numbers, their marks, again and again and again. Very quickly, the code becomes messy. And when beginners first start programming, this is actually a very common problem. How do we manage large amounts of similar data without creating chaos in the code? Now you might think, what exactly makes something an object? Well, almost every object usually has two things: properties and behavior. Let's understand this using a car. A car has a color, a brand, a speed, and a model number. These are all properties because they describe the car. But a car can also do things. It can start, it can stop, it can accelerate, it can turn. These are behaviors because they describe what the car can actually do. And this same idea exists everywhere around us. For example, think about a student. A student has a name, an age, a roll number, and marks. These are properties. And what can a student do? A student can study, attend classes, submit assignments, and give exams. These are behaviors. In programming, we also try to represent real-world things like cars, students, bank accounts, and phones. And those real-world representations inside a program are called objects. So remember this. An object is simply a real-world entity represented inside a program. And once you understand objects, understanding classes becomes much easier. Now imagine we want to store information about students in a school. At first, it might seem very easy. We could simply create separate variables for every student. Something like this: string student1 name equals Rahul, int student1 age equals 20, string student2 name equals Aman, int student2 age equals 21. And this process keeps repeating again and again. Now imagine doing this for hundreds or even thousands of students. Very quickly, the code starts becoming messy, difficult to manage, and difficult to understand. At this point, even the programmer starts questioning life. So what exactly is a class? A class is simply a blueprint. Let's understand this with a real-life example. Imagine an architect designing a house. Before the real house is built, a blueprint is created. That blueprint describes where the rooms should be, where the doors should be, and how the structure should look. But the blueprint itself is not the real house. It is only a plan, a structure, a template. Classes work in a very similar way in programming. A class describes what properties an object should have and what behaviors an object should perform. For example, let's create a student class. Inside the student class, we might have name, age, and roll number. These are properties because they describe the student. And later, we can also add behaviors like study, attend class, or submit assignment. So the class is not the actual student. It is only the blueprint used to create students. Now comes the interesting part. If a class is a blueprint, then how do we create actual students from it? This is where objects are created. Now, is1 is an object, and is2 is another object, and both of them are created using the same student class blueprint. But here's the interesting thing. Even though both objects came from the same class, they can still store different data. For example, s1.name equals Rahul, s1.age equals 20, and s2.name equals Aman, s2.age equals 21. So both students are created using the same blueprint, but both objects are completely separate from each other. And this is exactly what makes object-oriented programming so powerful. Now let's simplify everything even more. Imagine a cookie cutter. That cutter gives shape to multiple cookies. The cutter itself is not the cookie. It is only the template used to create cookies. Classes work in exactly the same way. A class acts like the cookie cutter, and objects are the actual things created using that class. One student class can create many student objects. One car class can create many car objects. One bank account class can create many bank account objects. So instead of writing separate variables again and again, programmers simply create a class once, and then they create as many objects as they need from that class. This makes the code more organized, easier to manage, and much easier to understand. And this is one of the main reasons why object-oriented programming became so popular. So let's quickly revise everything we learned in this video. An object represents a real-world entity inside a program. Objects have properties and behaviors. A class is a blueprint that defines the structure of those objects. And using a single class, we can create multiple objects. A class is a blueprint that defines the structure of those objects. And using a single class, we can create multiple objects. Once you understand this idea clearly, learning advanced OOP concepts becomes much easier. And now, you officially understand the basics of classes and objects in Java. For many beginners, object-oriented programming feels confusing in the beginning. But once you understand the relationship between classes and objects, things start becoming much more clear. In the next video, we'll explore encapsulation and understand how data protection works in object-oriented programming. So stay connected and keep learning.